Staring at my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be taking a look at dictionaries in Python. So what is a dictionary? A dictionary is a built-in type in Python that's the data structure that lets us map keys to values. Each one of these keys must be unique, and we can't have duplicate keys. Values, on the other hand, can be duplicated, so two different keys can map to the same value. Let's take a look at a little bit of a visualization of what this looks like. So the idea behind a dictionary is that we have some set of keys, in this case names like Alice, Bob, and Charlie, and we want to map these each to a specific value. Some of them might map to the same value, but each key should be unique. So how can we do that? Well, we can do that using dictionaries in Python. And we define a dictionary using curly braces, like we can see here in the first bullet point. Keys and values are separated by a colon, and pairs are separated by commas. Again, keys must be unique, and they can be any immutable type. They could be strings, numbers, and tuples, but they couldn't be something like a list, which is mutable. Values, on the other hand, can be of any type, and they don't need to be unique. Let's take a look at an example. And here we have a dictionary named person ages. And what this dictionary does is it maps a string value, which is the person's name, to presumably their age, which is an integer value. So Alice is 27, Bob is 20, Charlie is also 20, and so on. Let's take a closer look and try to understand how this works. So just like with lists, when we assign a dictionary to a variable, it's actually creating a reference to that dictionary in the computer's memory. So somewhere in the computer's memory, we have a block with the values 27, 20, 20, and 38. And person's age is going to have a reference that leads us to that block in memory. This being a reference is important because it does affect how we copy dictionaries, just like we saw with lists. So the difference between dictionaries and lists is we don't reference these values like 27, 20, or 38 by an index number. So we can't say index 0, index 1, index 2, and so on. Instead, we reference these with a key. So Alice would point to 27, Bob would go to 20, Charlie would also go to 20, and so on. So if we had a line that looked like this, where we're assigning the value of person ages to another variable, like another dict, this means that instead of making a copy of the dictionary, it makes a copy of the reference, meaning that both of these variables now point to the same dictionary. Because dictionaries are immutable, meaning that we can add and remove key value pairs, as well as change the value a certain key is pointing at, this means that any changes to person ages will also be reflected in another dict. And any changes to another dict would also be reflected in person ages, because they're pointing at the same dictionary. So how do we actually make a copy of a dictionary? Well, just like with lists, where we had the list function that could copy a list, dictionaries have a dict function that can copy a dictionary. When we pass the dict function a dictionary, like person ages here, it's going to make an actual copy of that dictionary and copy the values instead of making a new reference to that object in the computer's memory. So here we change that last line a little bit to add this dict function, and we're passing it the dictionary person ages. What this does is instead of creating a new reference to person ages, it creates a copy, another dict. Now, any changes to another dict aren't going to be reflected in person ages, and any changes to person ages aren't going to be reflected in another dict. So just like with lists, with dictionaries, we have to be aware of if we're dealing with a reference to the same dictionary or if we're dealing with a copy of that dictionary. So how do we access the individual elements of a dictionary, those values for a corresponding key? Well, just like with lists and tuples, we use the square bracket notation. Except this time we don't give it an index number. We don't give it 1, 0, so on. We give it the key value. So we specify which key that we're looking for, and the dictionary will return whatever value is mapped to that key. If the key doesn't exist, then Python's going to raise a key error. Just like when we give an invalid index to a list, it causes an error. If we give an invalid key to a dictionary, it's going to give us a key error. Let's take a look at an example. Here we have that same dictionary, person ages, And now we've added 2 lines that print out 2 specific values. This first line here is accessing the value that is mapped from Alice. So see that in the square brackets, we're not putting a number. Instead, we're putting whatever the key is. So in some cases, that key could be a number. It can be any immutable type. In this case, because the type is a string, we specify Alice, and we would get the value 27. The next line is looking for Diana. And in this case, that maps to 38, so we would get the value 38 returned. So the output would be 27 for Alice and 38 for Diana. So if we wanted to see how we would reference each one of these values, it would simply be by using the name of the dictionary, or whatever variable that's referencing the dictionary. In this case, it's person age, and then we would give the key. So in this case, it's Alice, would give us 27, Bob 20, Charlie 20, and Diana 38. Note that the double quotes here are only needed because these are string keys. If this was a number key, like an integer, then we would just put the number. We wouldn't put quotes around. So how do we set or update values? I did say dictionaries were mutable, which means we can change the values certain keys are pointing to, as well as adding or removing keys. Well, just like with updating the value of a list, where we use the square bracket notation and then the assignment operator, we can do the same thing with a dictionary, except instead of an index number, we are going to give a key value. Now, there is one special thing about dictionaries. If the key already exists, the value is going to be updated in the dictionary, pretty much what you'd expect. But something special happens if the key does not exist. If that key doesn't exist in the dictionary, a new key value pair is going to be added to the dictionary, so there'll be a new entry for that key that maps to whatever value you set it to. So let's take a look at an example. And here we have that person ages dictionary again, except the lines under it now aren't retrieving values, they are setting or updating values. Let's take a closer look. So here again, we have a visualization of the person ages dictionary. And this first line here is going to update the value of Alice. So this first looks in the dictionary and sees if it can find a key for Alice. And since it does, it updates the value that is mapped to from the key Alice to now be 30. So Alice is now going to be mapped to the value 30. So if we tried to retrieve the value under key Alice, we now get a 30. The next line's a bit more interesting. So it's first going to look for the key Eve, and we'll see that it doesn't find it in the dictionary. If we were trying to retrieve the value of Eve, this would cause an error. But since we're setting the value, instead of causing an error, this actually adds a new key value pair to the dictionary. So in this case, since Eve wasn't in the dictionary, it adds a new key value pair that maps Eve to the value 19. Presumably, Eve is 19 years old. So when we finally print out this dictionary, we get output that looks like this. This is Python trying to represent the dictionary all in one line here. And it uses the same sort of format we've seen before for defining a dictionary. The key, colon, the value. So we've seen how we can update key value pairs and how we can add a new key value pair. But how do we remove one from the dictionary? Well, just like with lists, when we want to remove an element, we use the delete keyword. So that is DEL. But keep in mind that if you try to use delete on a key that doesn't exist in the dictionary, you will get a key error if that key doesn't exist yet. So it is good usually to check if the key exists before you try to delete it. Let's take a look at a simple example. Again, we have the person ages dictionary, but now we are deleting values from it. So here's our visualization of person ages again. And the first line deletes whatever is currently under key Alice. So deletes both the key and the value from the dictionary. So this would remove that Alice key value pair. The next line does the same thing, but for the key Diana. So this would remove Diana and the corresponding value of 38 from the dictionary. So when we print out this dictionary, we would get only 2 values in it, Bob 20 and Charlie 20. So in more complex programs, you definitely want to check if the key exists before you delete it. If it doesn't exist and you try to delete it, you're going to get a key value error. So how do you check if a key exists? Well, you may have guessed it already, but it's again with the in keyword. And we saw this with both strings and lists, except with a dictionary, it doesn't check if a value exists in the dictionary, it checks if a key exists in a dictionary. So in will return true or false, true if that key exists in the dictionary, and false if it doesn't exist in the dictionary. But keep in mind, this is case sensitive if you're using strings as your keys. Let's take a look at an example. And now we finally have a new dictionary. In this case, the dictionary holds an inventory of books, presumably for a bookstore. So the keys are the name of the book, and the values are how many of the copies of that book we have in stock. So this dictionary contains 3 keys: To Kill a Mockingbird, which we have 5 in stock, 1984, which we have 3 in stock, and The Great Gatsby, which we have 2 in stock. The lines underneath that are using the in keyword to see if 1984 is in stock. We combine this with a simple if statement. So if 1984 is in book inventory, that means that key exists in the inventory. It doesn't matter what the value is. It could be 0, -1, 5 billion. As long as that key is somewhere in that dictionary, that's going to return true. And if that returns true, we say the book 1984 is available. Otherwise, it's going to return the book 1984 is not in the inventory. Now, in a real-life scenario, we'd probably also want to check the value, because if the value was 0 or like -1, then the book wouldn't really be in stock. This is just checking if that key exists in our inventory. And the output is probably what you expect. Since 1984 is a key in this dictionary, it is going to return the book 1984 is available. Let's now take a look at a more interesting and complex example using dictionaries. And for this problem, we're going to make a bookstore inventory for our pretend bookstore. So we want to use dictionaries to track the inventory of a bookstore. We're going to give the user a few options. Option number 1 is view the current inventory. Option number 2 is to add a new book to the inventory. Option 3 is to update the quantity of a specific book that's in stock. Option number 4 will be to remove a book. And lastly, option number 5 will be to exit the program. For each book, we want to keep track of its name and the number of copies in stock. The initial stock in the bookstore should be represented by this dictionary that we already saw in a previous example that has 3 books: To Kill a Mockingbird, 1984, and The Great Gatsby. If you'd like, you can try coding this yourself. Otherwise, keep watching the video, and we're going to switch over to PyCharm and try coding it ourselves. Here we are in PyCharm, and I have just a little bit of starter code. So we just have a comment that's explaining the program, and we have that dictionary that was given to us. So now we want to create that menu system to allow the user to interact with this dictionary. And since this is a menu system where the user can keep inputting commands until they exit, we are going to need some big loop. In this case, we're going to use while loop, and we're going to set it to true. So we're going to keep running this loop forever until we encounter a break statement. Now, there are a lot of other loops we could use or other ways we could code this, but I find this to be fairly straightforward. Now, the first thing we're going to do in this loop is print out the menu to the user. That's pretty straightforward, so I'm going to fast forward me typing that out. Okay, so I've typed out the print lines. They're just going to show the user what their options are. And we are also taking their input of a number that represents their choice. So now we have to actually start coding these cases. But before we do that, let's just make sure our code is working. So we're going to try running this. And we can see we're getting our options, as well as it's asking for input. But of course, since we haven't coded everything, we can't actually exit yet. So we're just going to hit stop. Okay, so our first option is going to be viewing the book inventory. So let's start with that. So if the choice is equal to 1, then we are going to print out the inventory. So first we'll put a little title. And we're going to add a line break just to space things out. So we haven't covered how to loop through dictionaries yet. That'll be covered in the next part of this video. So instead of printing out the dictionary in a nice, easy to read format, I'm just going to print out how Python prints it. For now, that's fine, but you can always come back after we learn about loops and fix this to print out nicely. So our dictionary is book inventory. So that's fairly simple. It's just going to print out the dictionary. Let's also code in the second option before we test it again. So this is going to be choice 2, which is adding a new book to the dictionary. And before we do that, we need to know what book the user wants to add. So we're going to ask them for the title. And we also need to know how many of that book are in stock. And we're going to turn this into an integer. Again, this might be a problem if the user were to put something in silly like duck or pizza, but we're going to assume that they are smart enough to input a valid integer. If we wanted to, we could add more error checking. And we'll make this a nice F string to make it fancy. So we're going to reference the title they already put in and ask how many are in stock. Now that we have both the title and the quantity, we have to actually add this to our dictionary. And that's actually quite straightforward. We just have to use the assignment operator. So we're going to say book inventory, and the key is title, because the keys in our dictionary are the different titles, and the value is the number in stock, the quantity. And that's all we need to do. One thing to note, though, is if they tried to add a book that already exists, this would update the quantity for that book. If we didn't want that, we would have to add a little more error checking to check if that key is already in the dictionary. For now, we'll say that's fine. You can always add that in yours if you want to be more strict. So we can test this out before we keep adding new cases. So we're getting the options. Let's start by viewing the inventory. So we can see this is just printing it out like Python's default formatting. So we have To Kill a Mockingbird, 1984, and The Great Gatsby. So let's add a new book. Let's call it Python Programming. And how many do we have in stock? Let's say 42. And we can now print out the inventory again and see that it was added to our dictionary. We now have 42 copies of Python Programming. We haven't finished the program yet, so we can't exit, so we're just going to stop. Okay, let's add the next menu option, which is to update the quantity of a book. So we're going to ask the user for the book title to update, and then we're going to actually check if that book is in our dictionary, in our inventory. We're going to use the in keyword to do that. So if title, and we're going to see if the title is in the book inventory. So again, we're not dealing with capitalization, so this does have to be typed in exactly as it appears. If we wanted to make it case insensitive, we'd have to convert both to lowercase. But we can see we already have capitals here. So we'll leave it as case sensitive for now. So if the title's in the book inventory, then we can update the quantity. But first we need to know what that quantity is. So we're going to ask the user for it. Now we can be fancy and make this an F string again. So we got the quantity, we're going to input that from the user, we're storing it in quantity. Again, they do have to accurately enter a number, or we'd have to do more error checking. And now we'll update the quantity. And that's just like how we did before when we added the new book. And then we can print out that we actually added it. Actually, we should say updated. Okay, and we should probably add a print message like that to our add one too, just to make everything nice and clear. Okay, so now we have to deal with the case if that book is not in our inventory. In that case, we just want to print out an error to the user. Okay, we can test this out. It's always good to test as we go. So let's try updating the quantity of a book. 1984. We'll say we'll update that to 20. So it says updated 1984 to quantity of 20. Let's take a look at our inventory. And we can see it was correctly updated to 20. We also changed that case for adding a book to add that extra print message. And then whenever we change part of our code, we should test that again. So let's add a book. We'll just call it pizza. And we'll say 1,337 copies, just to be a bit silly. And we can see it's now printing added pizza with a quantity of 1,337. And that is correctly in our list. So we have 2 cases left to code. All right, the next case is going to be for the menu option 4, to remove a book. So the choice equals 4. Then we have to remove the book. But first we need to know what book we're removing, so we're going to ask the user. And we need to check if that book is in our dictionary. Otherwise, we'll get an error if we try to remove a book that doesn't exist. So the code for that is going to be exactly like we saw before, checking if it's in our inventory. If it is, then we want to remove it. And we do that with the delete keyword. So this should remove that key value pair for that title from our inventory. And if we didn't find it, we should tell the user that. And we should also probably tell them that it was deleted successfully if that happens. And the last menu option was to exit the program. That was option 5. And we simply can use break to do that, to get out of this loop. Now, the last thing we should do is to add an else case, just in case they put some invalid input. Okay, and we have nothing after this while loop, so once it exits, it's just going to be done. Let's test this out. So we added a remove book feature. Let's try that out. And the book we want to remove is 1984. It says remove 1984 from the inventory. We print out our inventory. We can see it is removed. Let's just double check and make sure everything's working again. I'll call this book Ducks. We have 2 of them. So we added ducks with a quantity of 2. You can see it in the inventory now. And let's try removing it. Well, let's actually try the error cases. So let's just put in some stuff that's not in there. And we can see that we didn't find that in our inventory. And I don't think we checked that for updating the quantity either. Another gibberish one. So those error cases are working. And let's also try the error case from the main menu. That's working okay too. Now we can try removing duck. I think it was ducks, plural. Remove ducks from the inventory, and it's gone. And now the last thing to test is exiting the program, which works. Program exited. So this seems to be working now. This does look a bit complicated, but once you break it down into the individual cases, it actually becomes fairly straightforward. And you'll find that a lot with a lot of the programming problems you're faced with. A big, complex program can be much more manageable when we break it into smaller parts. So instead of worrying how you could do all these menu options at once, concentrate at one at a time. Because when we break them down into individual ones, they are quite easy. For example, printing the inventory was just printing the value of the dictionary. To add a new book, we simply used that command that we saw before to add a new key value pair. Same thing with updating and removing. We just have an extra error check. So on their own, they are quite manageable. And another key thing is to test as you go. Don't try to write the whole code all at once. Let's switch back to the slides. Okay, we're back to the slides. And I do have a copy of the solution that I coded earlier, which should be fairly similar. Some of the wording might be a little bit different, but the logic should be about the same. You can also find a copy of this attached to our learning management system, so you don't have to worry about trying to copy it from a PDF. So next thing we need to look at is passing dictionaries to functions. And this is going to be almost exactly the same as lists. We can pass dictionaries to functions just like we pass lists to functions. And just like with lists, because dictionaries are mutable, any modifications to the dictionary inside of the function will affect the original dictionary outside of that function. So let's take a look at a simple example. So here we have a function called updateInfo. And this takes a dictionary. And this dictionary should have a name and a age key. So this is going to be a profile about some user in our system. And it's going to store things like their age and their name. Actually, that's all it's going to store in this example. So we can pass this to a function just fine. And inside that function, if we make a modification, like setting the age to 31, that's also going to be reflected back in the dictionary outside of the function. So when we set age equals 31 here, that updates the value that age maps to, and that is also reflected in the dictionary outside of the function. So when we run this, we get name Alice, age 31, and that is being printed by the print line that's outside of that function. So just like with lists, when we modify their values in a function, they also are going to be modified outside of a function because they're mutable. We can also return dictionaries from functions, just like we can return lists from functions. And this can be very useful because we could have functions that generates a new dictionary and returns a reference to that dictionary that we could use outside that function, or it might make modifications to that dictionary and then return a reference to that existing dictionary. So here's another simple example, again with that sort of user profile idea. And this function called createProfile is going to create a profile for a user based on some arguments that we send to the function. So the parameters of this function are going to be name, age, and phone. Phone is a little bit special because it has a default value of not available. So we don't have to provide that to the function. And inside this function, all we have is a simple line that creates a new dictionary. This is using the same syntax we saw before, but it's all on one line. We're not required to space it out onto multiple lines if we don't want to. In this case, we're not assigning it to a variable. Instead, we're just returning it, which is completely fine. Down here, we're actually calling the function. We're giving it 2 arguments, Bob for name and 25 for age. Because we don't provide phone, it's going to default to not available. Then the result of calling this function is going to be stored in new profile. So this function is going to return a reference to this dictionary, and then new profile is going to get that reference, and we can work with that dictionary outside of this function. So when we actually print this, it's going to print out the dictionary, which is going to be name Bob, age 25, and phone not available, because that was the default value. Now we're going to move on to talking about some common dictionary methods. So just like lists, strings, and other objects in Python, dictionaries have a number of methods associated with them that allow us to do some helpful things. This table shows some of the most common ones. The first one is get, and this reads a value from the dictionary. And this is very similar to simply accessing that value by using the square brackets. However, it has an extra feature, which is the default value. So it retrieves the value at a given key, but instead of throwing an error if that key doesn't exist, this will return the default value if that key doesn't exist. So in the example we can see in the table, we have a dictionary with 2 names, and they both correspond to some value. Maybe that's an age again. And we can see we have 2 print lines. The first one is using the get method to get the value at Jane, and it has a default value of NA. In this case, Jane is in the dictionary, so it returns 42. The next line tries to do the same thing, but with the name Chad. In this case, Chad is not in the dictionary, so it returns the default value, which is NA. This can be useful because it's sort of a safe way to check for a value in a dictionary that won't throw an error if the key doesn't exist. The next method is pop. And this works similarly to pop in lists, except it again has a default value. So this will remove and return the value at the given key. So that means it's going to return the value so you can access it in a variable. And it also removes that key value pair from the dictionary. If for some reason that key doesn't exist in the dictionary, then the default value is returned. So again, looking at a similar example, In this case, we have two names in the dictionary. So if we try to use pop on the key Ahmed, this will both remove that key value pair from the dictionary, so Ahmed won't be in the dictionary anymore, and it also returns the value, in this case 1. So this would output the values in the dictionary, which is only going to be Jane 42 because Ahmed was removed, but it also returns the value 1 and stores that in the variable val. The next three methods, items, keys, and values, are very helpful when we're looping through dictionaries, which we're going to talk about soon. These return what we call a view object, which is sort of a fancy list that is linked to the dictionary. So if the values in the dictionary change, the values in the view object also change. Items return a view object that's a list of tuples, and each tuple is a key value pair. So this is a representation of all the keys and values in the dictionary represented as a list of tuples. The keys method simply returns a list of all the keys, and the value method simply returns a list of all the values. But again, these are view objects, so they are linked to the dictionary, and we'll update with it. The examples here just show a basic example of how we can use this with a loop, but we're going to get into more detail on that very shortly. So now we're going to take a look at an example of using the get and pop methods. This is a little bit more involved than what we just saw in that table. So here is an example. And what this does is it creates a user profile dictionary. So this dictionary is going to have keys that represent different attributes about a user. So in this case, we have name. In this case, it's going to be John Doe. We have an age of 30 and an email of john@example.com. So after this dictionary is defined, we're going to do a few things on it. The first lines are going to be using the get method. First, we try to get the value of name. In this case, that key exists, so John Doe is returned and stored in username. Next, we try to get the value of phone. But there is no phone key in this dictionary, so the default value is used, which is not provided. So user phone is going to be equal to not provided. The next set of lines deal with the pop method. The first one tries to pop the key email. This means it's going to remove the key value pair for email, and it's going to return the value of that key. So john@example.com is going to be removed from the user profile, and it's going to be stored in removed email. The next line tries to use pop on the key address, but it also gives a default value of no address on file. In this case, there is no address key in the dictionary, so the default value of no address on file is returned and stored in non-existent address. The last set of commands simply output these different values. If we run this code, we would get this. So that first print command outputs the whole dictionary, at least it's in its current state after we did those pops. So it's only going to have the name key and the age key because we popped off the email key. The next line is going to output what's in username, which is John Doe, that was returned by the get. The phone value, user phone, is going to be not provided because that one didn't exist in the dictionary. So we got the default value of not provided. Removed email is going to be equal to the email that we used pop to remove from the dictionary, john@example.com. And the last one, which is going to be the non-existent address, is just going to be no address on file because we used pop, but address key didn't exist in the dictionary. So we got the default value, which is no address on file. These pop and get methods can be very helpful while we're working with dictionaries. And they're another thing to add to your list of methods to make your life a little bit easier in Python. So now we're going to talk about how we can iterate or loop over a dictionary. And there's a few different ways we can do this, depending on what exactly we're looping over. Are we looping over the keys? Are we looping over the values? Or are we looping over both, the key value pairs? The example we have on screen right now is probably the most basic version of looping over the keys. So in this case, we have that same for loop structure that we've seen many times now. But now the thing that we're looping over is the dictionary. In this example, the dictionary is called employee role, and it stores different roles for different employees. So Alice is a manager, Bob's an engineer, and Charlie is in HR. Now, the loop variable here, employee, is going to be equal to the current key. So for the first time the loop runs, it's going to be Alice, the second time Bob, third time Charlie, and so on for however many key value pairs we have in the dictionary, always equal to the key, not the value. So if we were to run this code, we would get the following output: Alice, Bob, and Charlie, which are all the keys in the dictionary. Now you might wonder about the ordering of dictionaries. Are dictionaries ordered? Well, in the most recent versions of Python, they are, but in older versions of Python, they're not. In the most recent versions, they're ordered by the order you add the key value pairs to the dictionary. Another thing we can do once we have the key in a loop is we can use that key to access the value. So in this example, we have the same dictionary, and the loop is running the same. It's running through all the different keys in employee role. But the difference here is we're not just printing out the key, we're also using that key to access the value. So here we can see that we are accessing the dictionary and we're returning the value at the given key. So the first time this loop runs, the key that's equal to employee is going to be Alice. So this line that we have highlighted right now is going to look up Alice in the dictionary and return the value manager. So this means when we run this code, we're going to get Alice has the role of manager, Bob has the role of engineer, and Charlie has the role of HR. So if we're looping over the keys for a dictionary, we can easily use that to look up the values in that dictionary. So Alice, Bob, and Charlie are coming from the loop variable employee, whereas manager, engineer, and HR are coming from our lookup of that key value here. Now we can also loop over the values of a dictionary. In this case, we would just get the different values like manager, engineer, and HR. The code is very similar to what we've already seen, but instead of looping over the dictionary, we loop over the result of calling the values method on the dictionary. This does return a view object, which is linked to the dictionary, but we can sort of think of that as a list of all the different values in the dictionary. So the first time this runs, it's going to be equal to manager, then engineer, then HR. So role each time is going to be updated to the different value, the next value in the dictionary. And the output would look like this: manager, engineer, HR, going through each different value. This can be a little less powerful than the previous example because it's a lot harder to go from the value back to the key. But if you only need to access the values, this is fine. And the last way we're going to look at to loop over a dictionary is to get both the key value pairs. And we can do that using the items method. The items method, we can think of that as returning a list of tuples, with each tuple being a pair of a key and a value. In reality, it's technically a view object, which links the result to the dictionary. So if the value in the dictionary changes, it also changes in the tuple, but we don't need to worry about any of that when we're using it with a for loop. So here we're calling the items method on the dictionary, and that's going to return that list of tuples, with each tuple representing a key value pair. Then we can see at the beginning of the loop, we have two different loop variables. The current key is going to be set to employee, and the current value is going to be set to role. So both of these loop variables are going to be updated each time this loop runs. So the first time, employee is going to be equal to Alice, and role is going to be equal to manager. When the loop restarts, it's going to be updated to Bob for employee and engineer for role. And then the last time, employee will be Charlie, and role will be HR. So the output would be the same as that previous example we saw, which would be Alice has the role of manager, Bob has the role of engineer, and Charlie has the role of HR. This makes our code a little bit cleaner and easier to use because we don't have to be specifying the key value in those square brackets. So to reiterate, Alice, Bob, and Charlie are coming from the employee loop variable, and the roles, manager, engineer, and HR, are coming from the role loop variable. So now, as a little bit of a homework problem, I have a problem here that you should try coding in PyCharm. It's going to be a little more complex than the examples we've seen, but don't worry, I have a solution posted to the learning management system, as well as in the slides. So what is the problem? It's create three functions: word frequency, print word frequency, and most frequent. The words frequency function should take a string argument and return a dictionary, which is going to contain the frequency of each word in the string. That's going to be how many times that word occurs in the given string. So if we had the words hello world in our string, we would have two entries in this dictionary. One for hello, which would be the key, and the value would be 1 because it occurred once. We'd also have a key value pair for world, in which case the key would be world, and the value would be 1 because it occurred once in the string. If the string was hello, hello, hello world, then the value for the key hello would be 3, and the value for world would still be 1. So however many times that word occurs in the string, it should be represented in the dictionary, but there should always be just one key value for that word. So the print word frequency function should take the dictionary returned by word frequency, that one that has keys for each word, and the values are the counts of how often it occurs, and it should print its contents to the console, one key value pair at a time, and give it some nice formatting. Lastly, the most frequent function should take that dictionary returned by word frequency, and it should return the word that occurs most frequently. In the event of a tie, it should just return the word that occurs first in the dictionary. So 3 functions. Word frequency is going to create a dictionary that calculates all those word counts. Print word frequency can print out that dictionary to the console. And most frequent word is going to search through that dictionary and return the word that occurs most frequently, the one that has the largest count. You should also add some code to test the function and to call each function. So I'm going to give this more as a homework problem rather than go through each step, but the solution is in the slides, and you can find that here. So try coding this, then if you run into any problems, take a look at the solution. And you can also find this as a Python file attached to our learning management system. And if you want to have an idea of what the output might look like, here we have a list of the word frequencies. So this was a dictionary returned by that word frequency function, and it was printed out using our print word frequency function. Then the last output, the most frequent word is in, comes from that function that finds the most frequent word. So you want to combine them together with a little bit of code so you can get output that looks something like this. But of course, you can test it with whatever sentence you want. In this case, the test sentence was the rain in Spain stays mainly in the plain. The plain in Spain is mainly wet when covered in rain, which is a bit of a silly sentence, but it works well for testing the different frequencies of words. That's all I have for you in this video. I highly recommend you try out that homework problem and then compare your solution to the one that I have posted. Thank you for watching, and have a great day.